So now we'll try to solve this question using the non-inertial frame method, right? So when we solve it using non-inertial frame method, all we need to understand is primarily we need to understand is the difference between inertial and the non-inertial frame. Now from this diagram, it should be clear to you that here we have the observer is observing the block with respect to this block. Okay. Earlier he was standing here on the ground and then visualizing the block. Now what is he doing? He is observing this block with respect to the block. Now it doesn't mean literally or physically that the man is standing on the block. No, because if he stands on the block, then there will be an added force of normal reaction. So that is what we're talking about. We're just trying to say that he is observing things with respect to the block. So it is not that the man is standing on the block. He is observing with respect to the block. Okay. Okay. So that's one point. Second, what is a non-inertial frame? Let's see that first. A non-inertial frame is a reference frame that is accelerating or rotating. So we have, what did we say non-inertial frame as? The block. What is the block doing? It is accelerating. What is the block doing? It is in a circular motion. In such frames, Newton's laws of motion do not apply in their simplest form. Why? Because there is a need of additional pseudo force or fictitious force or inertial force, which has to be added to. Why? Why has it to be added? Because to account for the acceleration of the frame itself. Okay. This basically translates. So this is, suppose this is point A and we have the stretched spring here. Attached to this is the block, and if there is an observer standing here and is observing this block from this point of view, then there will be two forces. One will be the force of tension, definitely, and the other would be the pseudo force which acts like this. Okay, things will become more clear when you make a note of this, draw this diagram, this as well, and try to read it on your own. Things will start making more sense to you. Okay, so I assume you are writing these things along with me. Now the next question comes up: why do we use a rotating frame? See, in rotating frame, the centrifugal pseudo force provides a simpler way to calculate the tension in the spring. Really important. Tension in the spring. Why? Because it allows us to treat the block as if it were in equilibrium. Now let me just bring this previous diagram here. Give me a second. Sorry to. So what this part is trying to explain is, if you were considering a rotating frame like this, right? You can say that this object here is in equilibrium. And when is this in equilibrium? When the tension in the string, which is moving like this, right, exactly balances the outward pseudo force, making it possible to solve for the tension directly. Okay, so basically what have we done? We have reduced this problem in such a way that all we need to do is consider this object in equilibrium by accounting for a new force, which is the pseudo force. Okay, now see, most of the students have a misconception here. Let me just clear this. This pseudo force is not actually a force. Similarly, this centripetal force here is not actually a force. It is some other force by virtue of which the object tends to be in a circular motion, and any force that causes an object to rotate will be causing a centripetal effect, and therefore it will be causing a centripetal force. So therefore it will be called as a centripetal force. So in this force here is the F centripetal, whereas the outward force here is what we call as the centrifugal force. What I'm trying to say is, these nomenclature they come into action depending upon the frame of reference. So you cannot choose an inertial frame, right? You cannot choose an inertial frame and then say that you're considering centrifugal force. No, because centrifugal force is a pseudo force, and pseudo force comes into picture only when we use a rotating frame, which is actually a non-inertial frame. Okay, so I hope things make sense here. Okay, just write down these things. It will become more clear to you. Okay, now how do we consider the pseudo force in the rotating frame? Because the string rotate, because of this rotating frame, I'm sorry, because this rotating frame is not an inertial frame. Why is it not an inertial frame? Because it is constantly changing direction. Why is it constantly changing direction? Because we know that in a circular motion, right? In a circular motion, every velocity is tangential at every point, right? It is tangential. We need to introduce a pseudo force to account for this effect of rotation. In this case, the centrifugal pseudo force appear to act outward away from the center point. So let's just try to explain you this concept one more time. So we can say here that the centripetal force act like this towards A, whereas the centrifugal force acts away from the point A. So this line here represents the F centripetal, whereas this represents the F centrifugal. Okay, and the magnitude of this force, which force? The centrifugal force, is given by m into omega square r. Why? Because this is in a circular motion. Okay, so to summarize, imagine sitting or moving along with the block. From this perspective, the block appears stationary relative to you, even though it is moving in a circular path around point A. So I hope you can make use of this diagram, right? Maybe I just try to bring in the diagram one more time so that things become really easy for you to understand. Okay. So let's say let us say this is the table here, right? And this object here is in circular motion, right? This object here is in circular motion. And what do we need to imagine? We need to imagine that we are sitting on the block, or we are trying to move along with the block. And from that perspective, what actually happens is velocity of the block will be equal to velocity of the observer, which means the relative velocity of the block with respect to the observer will be equal to 0. And it is in this case that we call the frame to be a rotating frame. Okay. Okay, which also reminds me that this is not inertial, this is non-inertial frame. Okay, so now from this perspective, the block appears stationary relative to you. Why does it appear stationary relative to you? Why? Because the relative velocity of the block with respect to the observer is equal to 0. This rotating frame rotates with a constant angular velocity omega, matching that of the block's angular velocity. Relative velocity of block will be equal to relative velocity of observer, or relative velocity of the frame. This magnitude is given by m into omega. It is not omega into 2r. It is f is equal to m into omega square r, right? So the rotating frame in this question is a frame of reference moving with the block as it rotates around the point. This is a point A. In this frame, the block appears to be at rest with a balance between the tension and the spring. Okay, so if you want to make a note only of the very limited topic, I think you can just draw this, and then you can represent that here the F, the pseudo force, right? F pseudo is balanced by F centri. This would suffix you the note. Okay. Now, since that we have done this, what can we do next? We can now try to solve the question. And how will you solve the question? Considering the non-inertial frame, sigma fx implies m into a is equal to 0. Why? Because the object is in equilibrium with respect to the observer who is standing on the block, which means the only two forces acting here will be F spring, and the other force would be the F pseudo. And since these two forces are vertically since this object is in equilibrium, we can say that vertically the normal reaction and the weight would be cancelled, right? So we can say that sigma Fy is equal to 0 and therefore N will be equal to mg. Now, if sigma Fx is equal to 0, forces acting towards the left, F spring, should be equal to force acting towards the right, which is force pseudo. What is F spring? F spring is kx. What is force pseudo? Mass of the block into acceleration of the block. What is acceleration of the block? It is acceleration of the circular motion. What is acceleration of circular motion? Omega square r, where what is r? R is the radius of the circular path. R is not equal to length of the spring. R is not equal to the natural length of the spring. In fact, what is R is equal to? R is here equal to the extended length of the spring. And what is extended length of the spring? It is equal to the natural length plus the extension, which is L plus X. Therefore, this equation becomes Kx is equal to m into omega square times L plus m into omega square X. Then I'll transpose this portion, right, this to the RHS, and what do we get? Kx minus omega square is equal to m into omega square into L. And then X, I'll take out what common from here. I'll take out this X as common. And what do we get? X into k minus m omega square is equal to m into omega square L. Therefore, X is equal to m omega square by k minus m omega square. Now, with reference to the given question here, what's the value of m? The value of m is 100 gram, 0.1. Angular velocity is 5 rad per second, 5 square. Length of the spring is 20 centimeter, 0.2. 7.5 minus 0.1 into 5. So 5 square is 25. 25 into 0.1 is 2.5. So this becomes 7.5 minus 2.5, which is 5. 25 into 0.02, it becomes 0.5. Multiplying by 10 on both numerator and denominator, what we get is 5 by 50, which is equal to 1 by 10, which is equal to 0.1. Therefore, X is equal to 0.1. And always keep this in mind. The question is to find out the tension in the spring. What is the tension in the spring? Tension in the spring is spring force, which is equal to K into X. And what is the value of K? The value of K is 7.5 from this question, 7.5. And what's the value of X? X we just found out to be 0.1, which gives us the answer as 0.75 Newton. The correct option being option B. See, I have taken much of your time. I do realize that, but what's the intent behind it? The intent behind is to show you that you can approach a question in both ways, in an inertial perspective as well as in a non-inertial perspective. Especially when it comes to numericals based on circular motion, if you try to do the questions based on a non-inertial perspective, then most of the time students don't consider the pseudo force, which actually makes them which actually makes it easy to solve the question by considering that object to be in equilibrium than to be in a motion, which helps you in calculating the problem easier. Okay. But having said that, I would also like to say that no matter which approach you use, you have to arrive at the final answer. Therefore, you will have to include all the necessary calculations. So you're not skipping any calculation by choosing a non-inertial frame. The conceptual difference comes into picture when you use inertial and non-inertial. That's it. You can solve the question in either ways and you will arrive at the same answer. Okay, so that's it with this question. I'm really sorry that I took a really somewhere around 14-15 minutes. It's too much for this one question. Sorry for that. Let's move on to the next question, which is okay. Now this again is based on work energy power, a very simple question based on application of differentiation and integration.